Alright, so my presentation is, my audience, I mean, is a freshman or sophomore class taking Intro to Computer Science here at Augsburg. And here we go. Okay, so at some point everyone has to learn their ABCs. It's kind of a general part of life. But not only do we have to remember it, but computers have to remember them too. But computers, they don't remember things like that like we do. So they have a whole system of memory set up that's all measured in a coordinate system of bytes, megabytes, kilobytes, terabytes, gigabytes, all these different systems of measurement for this information. I want to talk a little bit, which leads me to my main point. Just how much memory does it take for computers to remember a series of letters? Like the alphabet. For this presentation, I'm going to talk a little bit about my method for my experiment I set up and what my findings were, just to give a really good layout of each experiment that I did. And then I'm going to talk a little bit about what I found based on that information. Okay, so you might have guessed that we're very lucky in this day and age. We have so many technological wonders. One of those wonders is the power to store anything. We basically have tons of storage for basically anything and everything we can think of. We have terabyte to dodecahedron byte, whatever it is, like so many bytes of information. We can store hundreds of thousands of songs, videos, photos, any of things like this. But I feel like it kind of makes us forget what it used to be like to not have those things. So for my project, I'm really going into the past to look at to a point where we had computers that were the size of buildings. They would use tubes. They would light up. These computers would only have like 38 megabytes, or like, if you were really lucky, a gigabyte, or anything like that, just really small. That's the basis of my project, is to try to give us a good picture of what that would be like to have not very much to work with as far as memory. So anyway, what was my method like? So I created a really simple method process. It's only 8 steps, and the setup is really easy. You just have a computer, a text edit document, and a online database that you can reference whatever data needs to be referenced, and then a system for just like a monitor to display it on. I mean, the computer isn't the monitor, so you just need something to show that it's there. So that's really simple. Let's go into the actual method. So it's an 8-step process, like I said. You open the text document, you insert the variables into the document like A, B, C, D, and then you save the document onto the file menu. And then you rename the file whatever number of the project you were working on. Then you'd right-click on the file, save it to the desktop, and go to Properties. And after you click Properties, it'll show you exactly how many bytes the file takes up. Now what you do after that is you just take the file from the desktop and move it to your online database, like a cloud network, and have that tell you how many bytes of information it's storing, so that you have a reference point. And if the two don't add up, then this experiment was a failure, because now you have contradicting points of interest. And then you just repeat all 8 steps. That really the last step, 8, is repeat steps 1 through 8. And each time I would change what was saved in the document to kind of experiment and find out and get information about this. Okay, so my findings are really simple. I have this really cool chart that I typed up in a PowerPoint slide, and it's basically got like 4 columns. It has the number of which experiment I did, and then what type of file I saved my data in, and then how many bytes were stored for that experiment. And then my final one which is kind of the outlier, but it's very important. This part tells us exactly what variables I changed in the document. Okay, so let's talk a little bit about my findings. So my findings were capitalization when saving letters to a document really doesn't matter. It didn't affect any of the results. Like, I would put in A, B, and C into a text document, and I would save it, and then I would do the same thing again, except I'd make them all capitalized, and it would still be the same amount of bytes stored. So that leads me to conclude that there really is no need. There's no need to store caps of a certain letter or a certain word. And the second thing I was able to conclude for this was that spaces are really important. So for instance, if you have A, B, and C, sorry about that, and you put a space in between A and B, then what you get is, instead of 3 bytes, you get 4 bytes, which happened in a number of the experiments I did when I changed the spacing. Each one of those spaces has to be stored, I found out. So if I didn't, I would imagine that all those letters would be jumbled up together, and you wouldn't have any coherent words. So you'd have to store somehow the spaces in between, which I at first didn't notice or didn't realize. There was one more thing I wanted to conclude about my findings, and that was the fact that how many ever letters I put in was how many bytes was stored, which leads me to believe in a number of the experiments that each letter has 1 byte assigned to it. And that's pretty much true for all of my results. This is the part of the presentation where I talk a little bit about the weaknesses and strengths of my method, but really there weren't very many weaknesses. I mean, the fact that it was really long is the only thing that brought it down. And then I would talk about future implications. So future implications, there really aren't any. This is a project that would have been done that brings us into the past rather than the future. So really it'd just be more like, how would Microsoft Word be if you only had 38 megabytes to store it all on? It would just make it useless. You'd type 3 words, and then all of a sudden you've used all of your computer's hard drive space. And that's basically it for that. This is the point where I review. So we talked about my findings, my method, and a couple of my conclusions. Does anybody have any questions? And then I'd ask and I'd receive questions at this point about my method or my conclusions that I drew from the method. And yes, thank you for listening.